Okay, so for this video, I'll be explaining how to make use of Quicksort in C language. So my source for this lecture is tutorialspoint.com. So the objectives for this video is for the audience to understand and use Quicksort in a C program. Now, what is Quicksort? Quicksort is a divide and conquer algorithm. So the steps here is pick an element from an array and call it as the pivot element. And then we divide an unsorted array element into two arrays. If the value less than 5, so the value less than pivot element come under the first array, that's to the left of the pivot element. And the remaining elements with value greater than pivot element comes in the second sub array. And then we do this repeatedly until we have the sorted array. So let us try to explain that using these example elements here. So consider an example given below wherein P is the pivot element, L is the left pointer, and R is the right pointer. So the elements are 6, 3, 7, 2, 4, and 5. So first, we pick the first element as our pivot element, so 6. So basically what we're going to do here is, if this is our pivot element, all values lesser than this value will be placed to the left of this value, and all values higher than this will be placed to the right of this pivot element. So that's basically what we're going to do here. And then of course the half to the left of the pivot element will be again sorted, and also at the same time the values on the right of the array or the pivot element will also be sorted using the same algorithm. So it's a divide and conquer algorithm. So let's try to let's go on with the explanation of this. So first, this will be our pivot element. So it is 6, and this is our left and our right. So case is P is equal to 6, so right side of P is greater and left side of this is lesser. So sorry with the spelling. Okay, so P should be lesser than R. So if, let's say for example, we now compare this with this, it is wrong, because to the right of P should always be lesser, or to the right of P should always be higher than this. So if P is lesser than R, then that means it is P should always be lesser than R rather. But here in this case, 6 is not lesser than 5. So it is wrong. So what do? We swap their places. So our pivot now becomes this element, and we swap their places. So this becomes 5 and this becomes 6. And then now we compare our pivot 6 with our left value. Of course, it is okay because that's our initial left value. So that's okay. So P should be greater than L. Again, to the left of P should always be lesser than P. So P should always be greater than what is on our left. So again, if it is not, then we swap their places. So in this case, 6 is greater than 5. That's correct. So we just move our left to the next element. Is P higher than this? Yes. So move again to the next element. So that will be the next. So we are now on 7. Is P higher than this? So no. So what we're going to do, we swap their places. So this becomes 7 and this becomes 6, our new pivot pointers here. Then we now compare with the right one. So is 6, so again to the right should be higher. So if 6 is 6 lesser than 7, that's right. So that means we now move this one to the left. So just the opposite of our left pointer. So we subtract 1 to our R. So our R now becomes 4. This should be, the arrow should be pointing here. That should be our new R. So is, again, what is to the right of our pointer should be higher. So in this case now, 6 and 4, that's wrong. So what we're going to do, we swap their places. So that's now the our new pivot value. So we have here 4. So it's P. So we compare it now with the left one. Is the arrangement okay? So again, to the left of P should be lesser. So yes. So we move left to the next element. So here, is the position okay? So it's right. Then we move next to the left element. So you notice here that our P is now equal to R and L. So if you still move, L will be higher than R, which should not be. So in that case now, what is to the right of our pivot table is our values higher than this. But of course, in this example, we only have one element. And everything to the left of this are values lesser than the pivot element. So what we're going to do now is this becomes another subarray. And we're going to apply the same routine to this subarray. So the same, we pick pivot table and then the same routine, just like what we have done a while ago. And do the same thing also with this, but of course for this we only have one element, so there's no need to do that. So again, here the pivot now is in the fixed position, so that's our pivot value. All the left elements are less, so these are all values lesser than the pivot element. The right elements are greater than the pivot. Then we divide array into two subarrays. So this is the one subarray and this is the another subarray. And then we again apply quicksort to these subarrays. So here now, so this is the first subarray. This is our left. And then we compare it here. So it's wrong because all to the right of our pivot should be higher. So since it's wrong, we swap. We swap their places. So this becomes 5 and this becomes 2. So this becomes 5. This is now our new pivot table. And then now we compare it here with this. That's okay because to the left of our pointer is lesser. So we move to the next index. Is it okay? Yes. So we move to the next index. Is it still okay? Yes. So we move to the next index. So this will be our pivot and our. Then again, we can still divide until the time that it's already okay. But here it is already sorted. So here, now the pivot is in the fixed position. All the elements are less and sorted. The right elements are greater and are in sorted order. So the final sorted list is combining two subarrays. So we have now 2, 3, 4, 5, 6, and 7. So that's now the quicksort algorithm. So let's take a look at the code. So this is the quicksort algorithm. So we specify the first and the last element. Okay. So if first is lesser than last, because if that's not the case, then we should exit our quicksort algorithm. So if first is lesser than last, then we assign first as our pivot. So that's what we did last time. And then I is first, J is last. So I is our left and J is our right value. So while I is lesser than J, what do? We actually move our left by 1. That is when the number in I is lesser than the number in the pivot, and I is not equal is lesser than the last. So that's what we did last time. If the value they are in the correct position, we just move our left. The same is true with the right one. If they are in the correct position, we move our J. If not, then we swap. So we swap their places. So once we exit, we also swap their places of the pivot and the elements, and the pivot and this is the first element and the position of the pivot. We swap their places. Then after that, we do the sorting for our sub-array, our first half and second half. You notice that this function is calling itself. This is actually a recursive function. So in other words, these functions will be performing simultaneously, because after this, maybe the next array will again be divided, again be divided. So there will be several quicksort processing that will take place until the time that our array is sorted. That's why it's actually very fast. So this one is the first half. This is from first up to j minus 1. Well, j is actually our position of the pivot. And then here will be to the right of the pivot. So j plus 1 up to the last element. So that's what we do until the time that it is sorted. So here in this program, to demonstrate this, we have an array with 25 elements or integer. So we just generated random numbers, 25 random numbers. We apply quicksort from index 0 to 24. And then after that, we just display the value. So if we run the program, execute, compile and run. So you notice here that the elements are now sorted from highest to lowest. If we run again, so again from lowest to highest. So that is now the quicksort algorithm. Thank you very much for viewing this video.